This project title is Boiler Tube Failure Analysis, conducted at North Chennai Thermal Power Station, located at Attipattu, Chennai. External guide Mr. V. Thirukumaran, Assistant Engineer. Internal guide Mr. E. Balaji, Assistant Professor. Project members are myself, P. Balaji, K. Moganasundaram, P. Premkumar, and K. Venkatesh. Abstract. Boiler tubes in power plants have finite life because of prolonged exposure to high temperature, stress, and aggressive environment. Failure analysis is an engineering approach to determining how and why a component or equipment has failed. The general causes for failure of boiler tubes are structural loading, wear, corrosion, and latent defects. The main objective of failure analysis is to understand the root cause of the failure of the component in the future. The investigation included hard tensile test, hardness measurement, dimensional measurement, and microscope. Scope of work. Scope of work covers study of boiler tube failures in thermal power station and study the preventive measures to avoid tube failures in primary superheater zone. To conduct failure mode analysis of boiler tubes and to suggest and implement the remedial actions. To reduce the number of tube failures and thereby reducing the number of breakdowns. And to reduce the maintenance and lightening up expenditure. Boiler. Boiler is an enclosed vessel that provides a means for combustion heat to be transferred into water until it becomes heated water or steam. The hot water or steam under pressure is then usable for transferring the heat to a process. Water is a useful and cheap medium for transferring heat to a process. When water is boiled into steam, its volume increases about 1600 times, producing a force that is almost as explosive as gunpowder. This causes a boiler to be extremely dangerous equipment that must be treated with almost care. The process of heating a liquid until it reaches its gaseous state is called evaporation. Heat transfer modes: radiation, convection, and conduction. Radiation, which is the transfer of heat from a hot body to cold body without a conveying medium. Convection, a transfer of heat by a conveying medium such as air or water. Conduction, transfer of heat by actual physical contact molecule to molecule. Boiler types and classification. Fire tube or fire in tube boiler contain long steel tubes through which hot gases from a furnace pass and around which water to be converted to steam circulates. They have lower initial cost, more fuel efficiency, and much easier to operate, but they are limited generally to capacities of 25 tons per hour and pressure of 17.5 kg per centimeter square. Water tube or water in tube boilers, in which the conditions are reversed, with the water passing through the tubes and hot gases passing outside the tubes. These boilers can be of single or multiple drum type. These boilers can be built to any steam capacities and pressures and have much higher efficiencies than fire tube boilers. Boiler tube material: carbon steels and alloy steel. Carbon steel contains trace amount of alloying elements and accounts for 90% of total steel production. Carbon steels can be further categorized into three groups depending on their carbon content. Low carbon steel: a mild carbon steel contains up to 0.3% of carbon. Medium carbon steel contains 0.3 to 0.6% of carbon, and high carbon steel contains more than 0.6% of carbon. Alloy steels contain alloying elements such as manganese, silicon, nickel, titanium, copper, chromium, and aluminum in varying proportions in order to manipulate the steel's properties such as hardenability, corrosion resistance, strength, formability, weldability, and ductility. Applications for alloy steels include pipelines, auto parts, transformers, power generators, and electrics. Failure mechanisms. There are many different types of boiler tube failure mechanisms which can be sorted into 6 general categories: stress ruptures, water side corrosion, fire side corrosion, erosion, fatigue, and lack of quality control. Short-term overheating. Short-term overheating in water-cooled tubes occur because of abnormal coolant flow or excessive combustion gas temperature. As a result, the tubes are subjected to excessively high temperature, often hundreds of degrees, which results in rapid failure. Corrective actions. The unit can be long-term overheating is due to selection of incorrect materials, scale formation inside the tube, and waterside deposits. Corrective action: a tube shielding. Dissimilar weld joints. Dissimilar weld joints causes rupture for boiler tubes. This type of failure mainly occurs due to use of dissimilar metal rods for welding the tube. The prime location of dissimilar failures, metal weld failures, are superheaters and reheaters. Corrective actions are replacement of failed tubes and frequent inspections. Hydrogen damage is caused by corrosive reaction between steam and steel. The hydrogen that is released reacts with carbides to decarbonize the steel and forms methane gas at the boundaries. Results in wall loss due to corrosion and decreases the strength in material attacked by hydrogen. The damage usually occurs in areas of high heat flux. Flow disturbance includes tubes opposite to burners and tube bends. Corrective actions are chemical cleaning. High temperature creep. High temperature creep leads to stress rupture of boiler tubes. Causes for such failures are general blockage, incorrect material transition, and higher stress due to weld attachment. Corrective actions are tube shield lock, thermal spray coating may be performed to reduce the rate of wall thinning caused by corrosion or fatigue failure. It is due to improper flexibility, attachment weld corrosion, cold bend restriction to the thermal expansion, improper heat treatment, and contouring of welds. Corrective actions are replacement of the damaged tubing when the depth of the crack approaches the limit of the material to contain the internal pressure. Fly ash erosion. Ash is having abrasive action. It erodes the outer surface of tube in economizers, low temperature superheater, reheater region. The major causes of fly ash erosion are temperature of flue gas, high ash content in coal, high flue gas velocity, and high impingement angle of ash particle. Corrective actions are changing boiler operating conditions such as reducing load, balancing airflow, and preventing ash accumulation. Case study. The data shown in table pertaining to boiler tube failures for one of North Chennai Thermal Power Station in Attipattu of last 6 years is referred. The plant is of 210 megawatts generation capacity with the prime fuel used as pulverized coal. The major 4 areas of boilers are identified. Boiler tube failures are identified: water wall, economizer, low temperature superheater, and final superheater. The tube failure occurred in different zones with a loss in generation on account of tube failures were studied. Based on the data, it was found around 30% of failures occurred in economizer zone. Failure history of boiler tubes of past 6 years. The table shows the content which are collected from North Chennai Thermal Power Station and for the last 6 years. During the year 2008 to 2009, the total boiler tube failures are 10. In water wall, there are 2 failures. In economizer, there are 4 failures. And in final superheater, there are 1 failure. In low temperature superheater, there are 3 failures. And the total loss of power generation are 133.9 million units second. A further year, in 2009 to 2010, the total boiler tube failures are 23. Further 2010 to 2011, there are 17 boiler tube failures. Subsequently, for the year 2011 to 2012, there are 11, and for 2012 to 2013, 12 boiler tube failures, and for the year 2013 to 2014, the total boiler tube failures are 6. It is clearly shown that there are maximum failures occurred at the economizer. Suggestions provided are chromium and molybdenum addition to steel improve its resistance to cracking and decarbonization by forming carbides which are more thermodynamically stable than iron carbides. Therefore, carbon steel tubes used in boilers should be replaced by steels containing chromium and molybdenum. Type of chromium and molybdenum steel will depend upon the condition of the area where these tubes will be used. Overheating of the tubes should be avoided by effective cleaning of the steam side surface of the tubes and removing all tenacious deposits. During fabrication and assembly of the pipes with welded joints, care should be taken to avoid generation of stresses at the weld elements. If possible, high quality coal want to use to reduce the erosion of the boiler tube. Thank you.